When considering using one generator set to serve two separate buildings supplied by two different meters, and assuming the same owner for both buildings, it's important to understand the implications and requirements. The key component enabling this configuration is the use of two automatic transfer switches, often referred to as ATS. An automatic transfer switch is a device that automatically switches a load between two power sources, typically a primary source, which is the utility power, and a secondary source, which is the generator. Each building would have its own automatic transfer switch. When the utility power fails in one building, the automatic transfer switch for that building senses the outage and starts the generator, then transfers the building's electrical load to the generator. The other building would continue to operate on utility power until its own automatic transfer switch senses a power failure. Firstly, you must ensure that the generator is adequately sized to handle the combined load of both buildings. This requires a careful load calculation for each building to determine the maximum demand. Add these demands together and then factor in any diversity, which refers to the likelihood that not all loads will be operating at their maximum simultaneously. The generator's capacity should exceed the calculated combined demand to provide reliable backup power. Consider future expansion and add a buffer to the generator size. Sizing the generator correctly is crucial to prevent overloading and ensure both buildings receive the necessary power during an outage. A load calculation typically involves listing all electrical loads in each building, determining their power requirements in kilowatts or kilovolt amperes, and considering factors such as motor starting currents and the duty cycles of different equipment. Secondly, local electrical codes and regulations play a significant role. Many jurisdictions have specific requirements for generator installations, especially when serving multiple buildings. It is imperative to consult with local authorities and obtain the necessary permits before commencing the installation. Electrical codes may dictate specific wiring methods, grounding requirements, overcurrent protection, and disconnect means. Ensure the installation complies with the National Electrical Code, specifically Article 700. Or Article 701, depending on the criticality of the loads being served. Compliance with these codes ensures safety and prevents potential issues during inspections. These codes address emergency systems and legally required standby systems, respectively. Thirdly, the installation of the automatic transfer switches themselves must adhere to electrical codes and manufacturer's specifications. The automatic transfer switches must be properly rated for the voltage, amperage, and interrupting capacity required by the loads they serve. It is crucial to select automatic transfer switches that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, to ensure they meet safety standards. The wiring between the generator, automatic transfer switches, and distribution panels must be performed by qualified electricians, using appropriate wiring methods and materials. Proper grounding is essential for safety and to minimize the risk of electrical shock. Fourthly, consider the coordination of the automatic transfer switches. You'll need to configure the automatic transfer switches to operate seamlessly with the generator. This involves setting parameters such as voltage sensing thresholds, time delays for transfer, and engine starting sequences. Some automatic transfer switches offer advanced features such as load shedding, which can prioritize critical loads during an extended outage. Load shedding can prevent the generator from being overloaded if the combined demand exceeds its capacity. The automatic transfer switches should also have manual override capabilities to allow for testing and maintenance. Proper coordination of the automatic transfer switches ensures a smooth and reliable transition between utility power and generator power. Fifthly, regular maintenance of the generator set is vital. Generators require periodic inspections, oil changes, filter replacements, and testing to ensure they are in optimal operating condition. A preventative maintenance program should be established to identify and address potential issues before they lead to a failure. The generator should be load tested regularly to verify its capacity and performance. Fuel level should be monitored and replenished as needed, and the battery should be checked to ensure it can reliably start the engine. Proper maintenance extends the life of the generator and ensures it is ready to provide backup power when needed. Sixthly, the location of the generator is an important consideration. The generator should be installed in a well-ventilated area, protected from the elements, and accessible for maintenance. Noise level should be considered, especially in residential areas. Local zoning regulations may dictate specific requirements for generator placement, such as setbacks from property lines and noise restrictions. The generator should be installed on a concrete pad to provide a stable and level surface. Proper ventilation is essential to prevent overheating and ensure the generator operates efficiently. Seventhly, consider fuel supply for the generator. Generators can be powered by various fuels, such as natural gas, propane, or diesel. The choice of fuel depends on factors such as availability, cost, and environmental considerations. Natural gas is often a convenient option if it is readily available, but it may be interrupted during a natural disaster. Propane and diesel offer greater energy density and can be stored on site, providing a more reliable fuel supply. However, diesel fuel requires periodic testing and treatment to prevent degradation. Fuel supply system must be designed and installed in accordance with applicable codes and regulations. This includes proper sizing of fuel lines, storage tanks, and venting systems. Eighthly, ensure proper grounding. Grounding is a critical safety feature of any electrical system, and it is especially important for generator installations. The generator, automatic transfer switches, and distribution panels must be properly grounded to provide a low impedance path for fault currents. This helps to protect against electrical shock and minimize the risk of equipment damage. The grounding system should comply with the National Electrical Code requirements, specifically Article 250. This includes the use of grounding electrodes, bonding conductors, and equipment grounding conductors. Ninthly, consider surge protection. Power surges can damage sensitive electronic equipment, especially during a power outage or transfer between power sources. Surge protection devices should be installed at the main distribution panels to protect against voltage spikes and transient currents. Surge protection devices divert excess energy to ground, preventing it from reaching sensitive equipment. The surge protection devices should be properly rated for the voltage and current levels of the electrical system. Regular testing and replacement of surge protection devices are necessary to ensure they are functioning properly. Tenthly, consider remote monitoring. Modern generators and automatic transfer switches often offer remote monitoring capabilities. This allows you to monitor the status of the generator from a remote location, such as a computer or smartphone. Remote monitoring can provide real-time data on generator performance, fuel levels, and system status. It can also alert you to potential problems such as low fuel levels or high temperatures. Remote monitoring can improve the reliability and efficiency of the generator system. 11thly, interlocks between the utility and generator sources are essential. Interlocks prevent the accidental paralleling of the generator and utility sources, which can cause damage to equipment and create a safety hazard. The automatic transfer switches are designed to provide this interlock function, ensuring that only one power source can be connected to the load at any given time. Manual transfer switches, if used, must also have interlock mechanisms to prevent backfeeding into the utility grid. Proper interlocks are crucial for the safety of utility workers and the protection of the electrical system. 12thly, consider the environmental impact of the generator. Generators produce emissions such as carbon dioxide, nitrogen oxides, and particulate matter. It is important to select a generator that meets applicable environmental regulations. Consider using a generator with emission control technologies such as catalytic converters or diesel particulate filters. Also, ensure that the generator is properly maintained to minimize emissions. The location of the generator should also be considered to minimize the impact on air quality and noise levels in the surrounding area. 13thly, address labeling and documentation. Proper labeling and documentation are essential for the safe and efficient operation of the generator system. All components, including the generator, automatic transfer switches, and distribution panels, should be clearly labeled with their function and voltage ratings. Wiring diagrams and system documentation should be kept on site for reference. This documentation should include information on the generator specifications, maintenance procedures, and troubleshooting tips. Proper labeling and documentation can prevent confusion and ensure that the system is properly operated and maintained. 14thly, consider potential future needs. When selecting a generator and designing the system, consider potential future needs. Will the buildings require more power in the future? Will new equipment be added that will increase the load? It is wise to select a generator that has sufficient capacity to handle future growth. Also, consider the possibility of adding additional automatic transfer switches or expanding the system to serve additional loads. Planning for future needs can save time and money in the long run. 15thly, adhere to the manufacturer's recommendations. Always follow the manufacturer's recommendations for installation, operation, and maintenance of the generator and automatic transfer switches. The manufacturer's documentation provides valuable information on the proper use of the equipment. Failure to follow the manufacturer's recommendations can void the warranty and create safety hazards. The manufacturer's recommendations should be followed closely to ensure the reliable and safe operation of the generator system. 16thly, consider professional installation. Installing a generator system is a complex task that requires specialized knowledge and skills. It is best to hire a qualified electrician or generator technician to perform the installation. A professional installer will ensure that the system is installed in accordance with applicable codes and regulations. They will also ensure that the system is properly grounded, wired, and tested. A professional installation can provide peace of mind and ensure that the generator system will operate reliably when needed. 17thly, consider testing after installation. After the generator system is installed, it is important to test it thoroughly to ensure that it is functioning properly. This includes testing the automatic transfer switches to verify that they are transferring the load correctly. It also includes load testing the generator to verify that it can handle the combined load of both buildings. Any problems that are identified during testing should be corrected before the system is put into service. Thorough testing can prevent problems and ensure that the generator system will operate reliably when needed. 18thly, consider periodic inspections. Regular inspections of the generator system are important to identify potential problems before they lead to a failure. These inspections should include checking the generator's oil level, coolant level, and battery voltage. The automatic transfer switches should also be inspected to ensure that they are functioning properly. Any problems that are identified during inspections should be corrected promptly. Periodic inspections can extend the life of the generator system and ensure that it is ready to provide backup power when needed. 19thly, consider automatic startup. Automatic startup is a feature that allows the generator to start automatically when the utility power fails. This feature is typically controlled by the automatic transfer switches. Automatic startup can provide seamless backup power without any manual intervention. It is important to ensure that the automatic startup feature is functioning properly and that the generator is ready to start at any time. 20thly, consider load management. Load management is the process of controlling the electrical loads connected to the generator to prevent overloading. This can be accomplished by shedding non-essential loads during an outage. Load management can extend the runtime of the generator and prevent it from being damaged by overloading. Automatic transfer switches with load shedding capabilities can be used to automate this process. 21stly, ensure proper ventilation. Generators produce heat and exhaust gases, so proper ventilation is essential to prevent overheating and carbon monoxide poisoning. The generator should be installed in a well-ventilated area, away from any enclosed spaces. The exhaust gases should be vented outside, away from any windows or doors. Carbon monoxide detectors should be installed in any nearby buildings to provide early warning of a dangerous buildup of carbon monoxide. 22ndly, consider noise reduction. Generators can be noisy, so it is important to consider noise reduction measures. The generator should be installed away from any noise-sensitive areas, such as bedrooms or living rooms. Noise barriers can be used to reduce the amount of noise that is transmitted to nearby buildings. Generators with noise reduction enclosures are also available. 23rd, consider the cost. The cost of installing and maintaining a generator system can be significant. It is important to consider all of the costs involved, including the cost of the generator, automatic transfer switches, installation, fuel, maintenance, and repairs. A cost-benefit analysis should be performed to determine whether the benefits of having a generator system outweigh the costs. 24th, consider the environmental regulations. Generators can be subject to environmental regulations such as air quality regulations and noise regulations. It is important to comply with all applicable environmental regulations. This may require obtaining permits, installing emission control equipment, or implementing noise reduction measures. 25th, consider the permits and inspections. Installing a generator system typically requires obtaining permits from local authorities. The system may also be subject to inspections to ensure that it complies with applicable codes and regulations. It is important to obtain all necessary permits and pass all required inspections before putting the system into service. 26th, consider professional maintenance. Regular maintenance is essential to ensure that the generator system operates reliably. It is best to hire a qualified generator technician to perform the maintenance. A professional technician will have the knowledge and skills to properly maintain the system and identify any potential problems. Professional maintenance can extend the life of the generator system and prevent costly repairs. 27th, ensure emergency contact information. Post emergency contact information near the generator system, including contact details for the electrician, generator technician, and local fire department. This information can be invaluable in case of an emergency. 28th, review insurance coverage. Review your insurance coverage to ensure that you are adequately protected in case of a generator failure or other related incidents. Your insurance policy may cover damage to the generator, damage to your property caused by the generator, or liability for injuries caused by the generator. 29th, regularly test the transfer switches. It's important to test the automatic transfer switches regularly. You should schedule a routine test, monthly or quarterly, for example. Testing ensures the transfer switches are ready for operation in case of a power outage. 30th, verify the operation of your transfer switches with the generator set. The purpose of this testing is to make sure the generator properly connects when either, or both, buildings lose utility power. In conclusion, providing power to two buildings via one generator is very possible with the use of two automatic transfer switches. This is assuming that both are under the same ownership. It is imperative to comply with local codes and regulations. This ensures safety and prevents potential issues during inspections. Remember to consult with local authorities and obtain the necessary permits before commencing the installation.